Welcome to This Explainer. Today, we are breaking down the single most fundamental concept you need for machine learning in Python: variables. Everything, and I mean everything, starts right here.
So, we see all this incredible stuff happening with machine learning every day, right? But have you ever really stopped and wondered how it actually works at the most basic level? How does a machine really start to learn from data? You'd probably guess it all starts with some crazy, complex math. But the surprising truth is, it all begins with an idea so simple you can picture it in your head right now: a labeled box. That simple concept is the key to everything else.
Okay, so let's dive right into this and figure out what that labeled box really is in the world of code.
Yep, that's it. A variable is just a container for information, and in machine learning, these containers are, well, they're essential. They hold your input data, the settings for your model, like a learning rate, and even the results it spits out, like accuracy scores.
And at its core, it's this super simple structure. A name equals a value. When you write x equals 5, you're basically telling Python, hey, create a box, stick a label on it that says x, and put the number 5 inside. And here's the really cool part. You don't even have to tell Python it's a number. It's smart enough to figure that out all by itself.
All right, next up, let's talk about the rules of the game. Because how you name your variables becomes incredibly important, especially when your machine learning projects start getting bigger and more complex. Clarity is just everything.
Now, the rules here are pretty simple, but they are absolutely critical. A name like learning_rate with that underscore works perfectly. But if you try to start a name with a number or use a hyphen instead of an underscore, your code is just going to break. Trust me, following these simple rules will save you so many headaches down the road.
Okay, pro tip time. If you want to write code that you and your team can actually understand weeks from now, you got to follow the professional standard. Use lowercase with underscores. Be descriptive. I mean, input vector is infinitely clearer than just IV, right? And finally, stay away from words Python reserves for its own commands, like class or def. This isn't just about following rules. It's about making your work readable and, actually collaborative.
Okay, so we have our boxes. Now let's look at the different kinds of stuff you can store in these boxes. Think of this as your personal toolbox for any machine learning task. See, each data type is like a specific tool for a specific job. You've got numbers, like integers and floats, and those are perfect for things like learning rates. Then you have strings for text, maybe for your model names. Lists are perfect for holding your actual feature data. That's the raw information you're going to feed into your model. And dictionaries, they are fantastic for storing all your model's settings, what we call hyperparameters, all neatly in one place.
So knowing the rules is great, but honestly, knowing how to avoid the common mistakes, that's what's going to save you hours of frustrating debugging later on.
Okay, first pro tip. If you have a value that should never ever change while your program is running, like a fixed learning rate, write its name in all capital letters. This is like a universal signal to other programmers and, honestly, to your future self to just leave this value alone.
Next up is a concept that trips up so many developers: scope. It's really just a fancy word for where a variable lives. Think of it like this: what happens in a function stays in a function. A variable you create inside is totally separate from any variable that happens to have the same name outside. Let me show you what I mean. Okay, here's a perfect example. We start with a variable called score, set to 90. Then, inside a function, we declare a brand new local score and set it to 100. But as soon as that function is done running, its local variable just vanishes. And the original score outside, it's still 90, completely unchanged. Forgetting about this separation is, I'm not kidding, one of the most common sources of bugs in programming.
And last but not least, a little word of caution. Python is super flexible. It lets you change a variable's data type whenever you want. You can start with x as a number and then later decide to make it a piece of text. Now, while that can be useful, it can also lead to some really unexpected errors in your machine learning code if your model is sitting there expecting a number and suddenly gets a word. So you've got to be careful.
Okay, enough theory. Let's see how all these concepts, the naming, the data types, the calculations, how they all come together in a practical, real-world machine learning example. And we're going to use a really powerful library called NumPy to do it.
All right, here we go. First, we define our input features in a variable we'll call x. Then we create our model's weights. This is the stuff it has learned in a variable w. And finally, we add a bias term. See how those descriptive names make it instantly clear what each part is doing?
And now for the magic. We combine them all in one clean line of code to calculate the final output. This single line, believe it or not, is a super simplified version of what happens inside a single neuron in a neural network. It's taking inputs, applying weights, and adding a bias.
And the result of that entire calculation is 2.1. That's it. We just took a few labeled boxes, combined them in a meaningful way, and produced a brand new piece of information, a prediction. You've literally just seen the absolute core of machine learning in action.
So let's just put it all in one handy cheat sheet. Everything we've covered, from a super basic assignment like x equals 5 to conventions like using all caps for constants, this right here forms the toolkit you'll be using every single day. If you can master these simple ideas, you've totally mastered the foundation of all machine learning code.